Welcome, everybody. Thank you for coming. My name is Alex. I'm one of the co-organizers for Django Boston. So I think we're going to go ahead and get started. Wi-Fi password is up there if you need it. Thank you, Klaviyo, for hosting us. Again, wonderful space. We're all very excited to be here. If you need to use the restroom, there is a restroom for men. You walk all the way back. You'll see kind of like these, I'm not sure how to describe, like, I think Chinese looking, like a wall kind of a thing. You can take a right and there's a restroom back there. And then I believe there's a one for women over this way, and then a gender neutral one out by the elevator. So a few different restrooms to choose from. All right, so tonight we'll have Paul, who will be giving a really cool talk on like scaling up and how Klaviyo handled Black Friday. So it should be really interesting. But before we get into that, I'd like to turn over to Andrew from Klaviyo, who'll just tell us a little bit about Klaviyo.
Hey everybody, how's it going? Yeah, so I don't want to monopolize the time. I want you to get the chance to hear from Paul. Yeah, so Paul has been helping Klaviyo scale for the last few years now, and so really proud of what we've accomplished. So yeah, Klaviyo has scaled from being a bootstrap company like out of MIT and Harvard into having like 8,000 plus customers and really helping power about $1 billion in like e-commerce transactions last year. Yeah, so we're pretty proud of what we're doing. We process about 1 billion e-commerce events every week right now. And yeah, so this is our busy season. So like Black Friday, Cyber Monday, essentially our Super Bowl. It's the biggest days of the year for both us as well as our customers. And yeah, so it's definitely like a day we are actually here in the office. We're not watching, college football or things like that. We're actually here making sure that everyone that is buying things on a store that is not Amazon.com actually has a great experience. And also you go and check out if you actually abandon your shopping carts and don't do things like that. So yeah, we're happy to talk more about scalability and things like that. But yeah, at our heart is a lot of like large scale Django, and we're really, really proud of like all the open source software we use. So feel free to come talk to us. But yeah, here's Paul.
Just like maybe one or two more announcements before I turn it over. So just so you all know, our next event is October 4th. It's gonna be at Path AI. There'll be 2 talks, and that is for Django Con, kind of like practice. So be very cool. Please come to that. And we're always looking for new speakers. We don't have anything planned beyond October, but keep us in mind if you have a talk you think you'd really like to give, like reach out to me or John, and we'd love to talk to you about it. So now I'd like to turn over to Paul.
I think this should, Thanks, guys. All right, yep, there I am. Hey, I'm Paul. I'm a site reliability engineer here at Klaviyo. Andrew gave a pretty good overview of what we do. We are essentially in the e-commerce business because that's the business that our customers are in. And so Black Friday, Cyber Monday is our huge scale event. And I'll start by talking about what it is exactly we do, and then I'll talk about what's hard about scaling that out to serve large numbers of requests and different kinds of requests. So we're a marketing platform, and you can compare us to a sort of traditional ESP, email service provider like MailChimp or Constant Contact, but we diverge from that in certain ways, specifically in how targeted some of our features are towards e-commerce. So this roughly represents the pipeline of a lot of our core features. And basically, if you think about what your traditional ESP does, it's like, all right, yeah, like you have lots of lists with your customers, you send a lot of email, and we tell you if it was delivered, if it bounced, opens, clicks. So, on the egress side, you send out a campaign, events come back in. For instance, we use SendGrid as our email sending partner. So we get webhooks from them. And all that information really tells you is about your deliverability. So it tells you, are these emails actually going out? It doesn't actually tell you anything about, did anybody buy something from my store because I sent them this? So it's kind of like a traditional and kind of tone-deaf way to communicate with people, because like, who wants to get emails all the time? Nobody. So what we try to do is make it a little more informed. And so we actually have a lot of code, as Andrew said, it's all Django. And we have an API. We have 2 calls that are pretty much like RPC, track and identify. What is someone doing on my store? Who are they? And we have a number of sort of out-of-the-box integrations with some of the most popular e-commerce platforms like Shopify, Magento, maybe some of the more popular ones. And so not only do we see how people are interacting with their email, we can also go, get Shopify webhooks or pull a Magento API and say, oh, look, so somebody opened this email at 11:30 a.m. that you sent at 11 a.m. And then at 11:35, they actually went and bought a shirt. So that's a little more helpful than just like, oh, somebody opened my email, I should send to them again. If they didn't buy a shirt, don't send to them again. Or, that's up to your discretion. But in any case, I'd go for the one that bought the shirt. So, it's this sort of feedback loop that we create. We have this segmentation engine that uses this event data so that you can, filter down your lists. So that's kind of just the business side of things. So that's what we do day to day. What's hard about that in terms of scaling? Emails need to go out on time. Some of our customers, and I'm going to make a distinction here. We call our customers companies, and we call their customers customers. It helps to not say our customers customers over and over. So our companies send out email. It doesn't matter if they're sent, if we have one customer that's sending 10,000 emails at 11, they have every right to have those emails go out at 11 as somebody who's sending 5 million, right? So you have some queuing concerns to worry about there. You want to make sure that nobody's getting stuck. Real-time event processing, webhooks coming in from the email provider, webhooks coming in and API calls being made to the e-commerce providers. And then we have a whole bunch of other things like if you're moving to us from MailChimp, a whole bunch of API calls going to them, syncing lists and things. So we have all this event data coming in. That's got to happen in real time. I'll talk more about that later. Or maybe I'll talk about it right now. Downstream workloads, right? Events inform other things, segmentation, sending emails based on what action someone's done. If I don't get an event, I can't do something that's supposed to be based off of that event. And like I said, it's this big feedback loop. So the real key phrase here is timeliness. I'll talk very quickly about just one example of how this feedback loop works, A/B campaigns. Say I want to test out 2 different subject lines, see which one's more effective than the other. I say like, yeah, I'm sending this out to 10,000 people, but I don't know which one I want to use. So I'll send out both variations to 500 each. And then I want to wait a little bit, collect open events, see which one got more opens, and then wait after 2 hours, 4 hours, and say, okay, this one did better. I'm going to send the rest out here. So what are we supposed to do if those events are backed up, right? You said, hey, check back in 2 hours, see how those opens went. And if we're having queue problems, if we're not keeping up with our message broker, then we can't really send out the rest of those emails, and our customers get mad, as they should. Event-based flows, I called campaigns kind of a tone-deaf way to send emails, and it kind of is. So like we also give you the ability to evaluate event data as it comes in, and then send out a single personal email to somebody. Say, oh, okay, you put something in your cart, but that was 24 hours ago. You didn't buy anything. So I'll say, hey, are you still interested? So if we didn't get that event, we don't know they put it in their cart, and we can't send them the email. So those are the high-level concerns. Periodicity. Black Friday, it's kind of a hint that this is something we care about. But there are different, we care about this kind of at different levels too. So every day, we know that we're going to have higher traffic volume at in the morning hours, 9 a.m., 10, 11 through 12. Those tend to be high email sending times. And then certain days of the week, we're also going to have some more. And then holiday weekends, every year around Labor Day, we get to kind of see if anything's cracking at the seams a couple months before Black Friday comes around. We tend to hit some of our infrastructure limits around then. And then the actual Black Friday, Cyber Monday scramble. So now I'll get into tech stuff. just kind of like some of the more notable things in our stack. We are completely based in AWS. So we have a ton of EC2 boxes. We use a lot of auto-scaling groups. The app itself is, I'll say, pretty much completely Django. We use Celery for asynchronous work. We're starting to branch out and do some microservices, some stuff in Node, some stuff in Flask. But as far as the things that I'm talking about today, these like high throughput requirement workloads, it's all Django. We use Cassandra very heavily. This is sort of the big data store for all that event data. Really good for time series data. We use it for counts too. I won't speak as highly about it for that as I will about time series data. Aurora RDS is, I put in parentheses there, email sending. The truth is we use MySQL on Aurora for all of our relational databases. But when I'm talking in the context of like what we need to scale for, I'm talking about a lot of, bulk DML specifically for email sending. We're reading tons of records in bulk, and we're doing like inserts and very frequent updates in a very short period of time. I've mentioned a few times queuing problems. We use RabbitMQ as a centralized queue system, and just sort of an honorable mention here for how we monitor things. So we've got Django statsd running on all of our workers and web servers. It's got a nice middleware, and then you have like decorator and context manager, so you can get nice timings and count data for all of your code. And we have Graphite and Grafana where we look at all that stuff. So all that, I'm just gonna sort of tell a couple of stories. One is gonna be about leading up to Black Friday 2016, and then we're gonna talk about Black Friday 2017. One of them went slightly better than the other, or one of them went a lot better than the other, let's say that. So I started personally February 2016. So when this came around, I was pretty new here. And that'll come into play at some point. And yeah, we were a team size of 7. It was super small. We have a technical CEO, co-founder. He spent a lot of time writing a ton of really complicated code, had some really complicated data models, and 6 engineers who were trying to figure it all out. So, we kind of had an idea of like what we needed to do to survive, but this is what we had going on. Cassandra, I mentioned we have time series data as well as counts. And we had one cluster that was kind of doing it all. It's basically a mixed workload, which if you've ever run a mixed workload anyway, it's probably going to cause some pain. Hard to get visibility into what's happening on an instance if one workload's causing problems, if another one is. So these boxes in this Cassandra cluster were very unhealthy. And early in the year, it was like, okay, well, we know what's going on here. We just need to split them out. We'll have the time series data in one cluster. We'll have the count data in another. Makes sense. We knew that we wanted to shard up some queues, right? I mentioned like we have customers that send to thousands. Sorry, I broke my own rule. Companies that send to thousands of customers and companies that send to millions of customers. We don't want people sending to 10,000 people sitting in line in Rabbit in one queue behind millions of customers. So it makes sense. You have fast lanes, medium lanes, slow lanes. You can break this up in terms of, the size of the batches going out. And then you can also get a little interesting with like the actual content of the email. Like we do some sort of fancy stuff like product feeds and coupons that require API requests. So, those are going to be slower. We want those to go in their own lane too. Event pipeline bottlenecks. We know that a lot of the work that we're doing to sort of make this whole thing work is, we're writing to a lot of different data stores. We have a lot of caches like Redis and some Memcache running in Elasticache, where we want to store different pieces of the event payload. We know that we're writing to MySQL. We know that we're writing to Cassandra. It's clear that we need good visibility into every element of this pipeline, and that, when we have a lot of these workloads happening concurrently, you're doing a lot of I/O, and that's probably going to be the bottleneck. So we wanted to make sure that we had really good visibility into that. And we thought, oh, we send a lot of email. Why don't we send a lot of fake email and see how it goes? So that's roughly how it went in 2016. we thought we had a lot of good ideas, and things went wrong. So what went wrong? This is probably, from a Django perspective at least, the most interesting bit. As I think most of you probably know, Django's preference for establishing database connections is to keep open a persistent connection to your database. So when you start up your Django process, first time you make a request to your database, it's going to make a connection, and it'll do its work, and it'll leave the connection open. It's a good idea. Reuse your resource. But when you are scaling from, like for 10x your normal amount of workers, and that's growing over the year, and you don't really remember what it was last year because last year didn't really matter because you didn't have that many customers. All of a sudden you're hitting limits. For us, this was an AWS MySQL. At most you have 16,000 open connections that you can have to your database. We didn't foresee that this was going to be a problem. It's pretty straightforward. It makes a lot of sense. More computers, more connections, but all of a sudden everything's unhappy. Web servers can't connect, so the site appears to be down. Our asynchronous celery workers can't connect, so we're getting failed tasks, getting logged out, saying, sorry, I couldn't send this email. I couldn't process this event. Try again later. So that's a lot of manual work. We had basically 7 engineers who kind of sort of knew what was going on, but not really. Learning a lot about, hey, what do you do when an email sends halfway and like half of the recipients are in sent state and half of them aren't? And like, what do you do with an A/B campaign that has no metrics, but it's been 10 hours and it was supposed to send after 2? So a lot of that kind of thing going on. Yeah, said that already. Postfix. So I talked about synthetic load testing. But we made a pretty common assumption, which is like, oh, like if anything breaks, it's going to be us, right? We're using this battle-tested, tried and true open source software. We're using MySQL. We're using postfix. But that's really not the whole piece. Like, we're sending a lot more email through our pipeline than we ever have, and then we're sending that same much more volume through postfix to SendGrid. Postfix had massive queue backups. They maintain their own internal queues. For anyone who doesn't know, postfix is kind of this package that you can get on, I think, like any Linux system that is a very common way to send email. And SendGrid supports sending through postfix. So that's what we do for email. And we thought like, oh, wow, we should really figure out how to test the entire pipeline next time, even outside of Klaviyo. That's kind of a hard problem because then you talk about dealing with partners and systems that are a black box to you. Event aggregation backup. Yeah, kind of like the A/B test, the A/B campaign thing that I mentioned before, like all those things bit us. We started a Cassandra migration. We didn't finish it. That was really painful. We started out in October preparing for this scale event. There were some estimates made. Again, I'll go back to 7 engineers. A lot of us kind of knew. Most of us, Cassandra was very opaque. We didn't really know a lot about it. We knew, oh yeah, okay, we're splitting out timelines and counters. That sounds good. And like they said it was going to take this long, so it should be fine. But we were double writing on the day. And that's just like the worst shape you can be in. And double writing was turned off eventually, but it was kind of sort of too late. So we have all these things. Webhooks. This is kind of an interesting one. When it comes to email, this is like our servers, doing massive amounts of writes and sending out data, and then webhooks coming in. So computers generating traffic for us. When you think about humans generating traffic, like, sites that are a little bigger than us, like, sure, yeah, you're going to get massive amounts of requests, but for like kind of a smaller shop that's growing, you'd think, can humans really click fast enough to give you like that much traffic? It turns out on Black Friday when they're buying a lot of stuff, they can. So these were all of our Shopify events that we just couldn't keep up with. And that, same story, downstream, things are breaking. Monitoring stack failure. This one was fun. I mentioned our trusty StatsD Graphite infrastructure. We had one box. It ran Grafana and Graphite and our StatsD server, taking all those UDP packets, and it's UDP. And, we're getting more and more metrics than we ever have before, and all of a sudden we're dropping data points. So we're like, oh, this is weird. We're not getting data. We can't see what's happening. No problem. Let's reboot it. So we reboot the instance, and it doesn't come back. So I can't take credit for this, but a couple of people, Andrew was one of them, very late at night Friday, went and like with very poor automation spun up a second statsd instance to make sure that we would see what was happening for the rest of the weekend. So we had some really hard lessons learned here. October, it's too late. Like 2015 may have been smooth sailing, but we clearly have grown way faster than that. What we saw is that, I think 2015, you might know better than me, like it was like 50 million emails, or 20 million was like the peak, and it was 80 million was our peak email sent in a day, 2016. So we're like, all right, so aside from the massive increase over the average daily email we're sending, we're doing about triple last year's Black Friday, Cyber Monday. So this is the kind of infrastructure that we aren't running every day, and we really need to start earlier. Small engineering team, very high bus factor on a lot of really critical information. If you have more people that have their SSH keys on boxes, or if you've been around a little long and you don't need SSH keys on boxes because you have better production access policies, you can have more people helping out. But we were very small, and a lot of people were basically learning after things went really bad. Don't migrate too close to a massive scale event. This one kind of goes without saying, but here we are today. If you're going to do synthetic load testing, figure out a way to incorporate external dependencies. Black Friday 2017. This is just sort of a visualization of how much more email we were sending. Team size 20, not overnight. We didn't hire 13 of the first people that we asked right after 2016 Black Friday, and they said yes. We, had people come on slowly over the year, but we started in June. We started a fair amount earlier, and we had a lot of people coming on. And with everything that we learned, we thought, all right, we've got some things to figure out. This event pipeline, we've got all these IO hits. We've got to figure those out. So Aurora DB latencies, we had a central database that failed because of connections, but the other side of that story is, as we're growing, we're storing tons of data. So the first thing that we thought to do, which was pretty straightforward, is, okay, like we'll do some functional sharding. We have a lot of customers. This table's getting big. We'll move that into its own Aurora database, but it's still just one massive table. So we need to figure out a strategy to shard that out. Monitoring, we can't have that go down, so we need to figure out how to make that high available. And aside from that, we've got a lot of single points of failure in our stateful systems. We had, some like Redis boxes that were kind of sort of not just caches, but actually databases that we needed to not go down, that kind of thing. Rabbit itself was a single point of failure, just one message bus. If that went out and we couldn't recover those messages from disk, like we're toast. Database connection management, that was clear as day. Load testing, it took a lot of work to get even that little bit that we did done. So we're like, yeah, got to start earlier, got to figure out, is there anything we can do with SendGrid to send them dummy payloads and stuff and make sure that that postfix isn't going to fail us again. So how do we prepare? Is that somebody say question? That's a very good question, both. Yeah, so a lot of time in terms of like, oh, okay, we need to do so for instance, we had a little library built on Twisted that can generate a lot of dummy payloads, but then also like, yeah, now all of a sudden you're storing all of this fake data to see like what your insert throughput is like in your databases. So yeah, it's both. Cassandra, when I talk about Cassandra, my mouth gets dry, so I'm gonna do this first. We didn't finish that first Cassandra migration until the beginning of 2017. I actually kind of like stepped in because the CEO said like, hey, I'm gonna try not to like do like critical like coding all the time anymore. So like, like the engineering team, you guys are gonna take over the Cassandra migration. We're like, great, we'll understand it this year. And we picked that up, and we had 2 clusters. And what we learned, once we split out those mixed workloads, the time series data, I don't know how many of you have any experience with Cassandra, but like they're based on this log structure and merge tree data structure, where it's all about very high write throughput to handle a lot of really fast concurrent writes, because you're just appending to a file in memory and flushing that and worrying about merging that stuff later. So like for time series data, it's great. But what we found was that our counters were absolutely the problem, because they have this primitive in Cassandra. It's a counter, and they don't really say it because they don't want to badmouth their technology. But you lose a lot of the performance benefits when you use counters in Cassandra, because all of a sudden you can't write without reading. You need to write. You need to read first. So you're always reading information potentially off of disk before you increment that count. And it's essentially like an anti-pattern to use counters in Cassandra. And it worked for us when we were smaller, but then we got to this point where it was just not okay. So we finished the first migration, and then we started a second one to split out some counters a little bit more to hopefully handle some of the disk throughput limitations that we had on EBS drives. Sharded queues. This worked for us the first time with email. We went back and said, like, this pattern can probably work for some other things. So, sharding out events was really helpful, just simply by having different companies. You can reasonably predict that after a company sends a campaign, they're going to get email events coming in very shortly after, and probably some e-commerce events even after that. And so by sharding this out, that sort of lets some of the smaller companies have their traffic come through too. So that's my work profile. My database connection, I'll get back to that a little bit later, because that sort of is related to some of the database sharding that we did that's coming up soon. Monitoring stack. Like I said, we needed to get that highly available. So, we moved from StatsD to Brubeck. It's a GitHub-based implementation of StatsD in C, so you can actually do multi-threading. We moved off of like the traditional Graphite stuff to use Go Carbon, which is Carbon, part of the Graphite stack written in Go, and had like a nice little army of those behind a relay. So gaining confidence in the monitoring stack. HA, non-managed stateful systems. For us, that basically meant anything that wasn't Aurora. So like we were running all that Redis and stuff in EC2. So started doing some stuff with Redis Sentinel, making sure that anything that wasn't actually a cache was going to tolerate an instance going down. And then the sharding. This was really cool work done by a number of people, really sort of like hacking around the way that Django does some stuff with models for you, and using like the meta objects. So basically, we were doing consistent hashing ourselves, and we said, hey, like based on this tenant ID, I know which shard I need to go to. So like I'm going to sort of superclass a model and do some things for our sharded models to route you, because like Django doesn't actually know about our sharding. That's just something that we manage ourselves. So there was a lot of work to make sure that we could do that. And then we thought, okay, like persistent connections, that's cool. We just need to do some connection pooling. So we started using proxy SQL. And then we were like, cache wherever we can. We were using Memcache and Elasticache. That had been kind of iffy for a few reasons. We learned a lot of things that we were doing a little poorly there. For instance, like we were getting things that just the size of the data was too big. So if it's more than Memcache allows, it's going to truncate it and throw it away and say like, I can't store this, but it's kind of silent. So you just don't get cache. Also, there are some limitations because this was an AWS managed thing. It was Elasticache. So, like we were finding that we were getting a lot of network throttling that was kind of either not in the docs or hard to find in the docs and a little hand wavy. Automated load testing. we thought like, yeah, we want to start much earlier, and we want to allow anybody to spin up something that represents the Klaviyo infrastructure in a dev environment, so that they can test any part of the event pipeline or the email sending pipeline with their own synthetic data, real fast, and then tear it all down so it's not staying around in production databases and costing us money. So we built this thing that we called Klaviyo Stack in 10, and that definitely worked out for finding certain issues in specifically some of our Redis caches. And like we thought, like the bullet says TV wall, but that's not really the punchline of the story to me here, is that we had a lot more engineers and we wanted more people to feel like they understood the systems and had visibility into them. So we put up all of our most important dashboards on a big TV, and like gave people ownership and said like, you own that latency dashboard. If that gets too high, you're the expert. You're the person that we're going to go to, who's going to let us know, that kind of thing. And oh, there it is. Yeah, cross-functional component ownership, making sure that you don't just have one person that knows everything, making sure that there's at least two people who understand a different part of the core components and can work through backups. So there's the TV wall. We all liked walking by it. We were at a modest 22 million when this picture was taken on that Black Friday. So it all went well. These are pictures of Klaviyo's getting on a private plane and going to see the Pats play in Buffalo, which was the thank you for smooth 2017 Black Friday. So yeah, everyone, it went a lot smoother. Still going to talk about failures, because who doesn't love failure? And like there were some things, and like you can always learn and grow and improve. So the webhooks backed up again, and that was kind of a quick one. We noticed this happening. It didn't get bad, and we thought like, oh well, we didn't shard this one out. What happens if we shard this? Just simple consistent hashing tenant ID, and that did it. It was just sort of one really busy customer backing up everybody else, and that was the end of that. Going into this year, webhooks is definitely something that's been another interesting challenge for other reasons. If you're interested in that, talk to me about it later. It's fun. We turned off one form of the segmentation we do. Specifically, it's this sort of nightly batch job that was more of a daily 16-hour job that started at night but finished in the afternoon. So that was getting a little hot, and we thought that was identified earlier as the safest thing to turn off. That wasn't going to really affect anything that we needed to get done on the day. We had we made some fixes to postfix, and we added proxy SQL, and they worked. But after the fact, we were like, hey, if either of those went down, we really wouldn't have known, first of all, if they did or what to do about it. So that's something that we sort of identified as like priorities to fix going into this year. I mentioned we did the really cool Klaviyo Stack in 10 thing. It was good, but a lot of us were saying like, it's cool that we're going and putting fake traffic through a Klaviyo clone, but we also had that huge tire fire last year with real traffic, and we know about a lot of those things to fix. So like, instead of building this artificial load thing, we could also work more on fixing the problems that we already know are there. So we were getting a little antsy and worried for a while because we were playing around in the dev environment, but we got it all done. Hacky solutions that we knew would create tech debt, sort of like 0-hour fixes. I mentioned that database sharding thing that we did. That's not really a cool pattern. Like your message bus shouldn't know which database its messages are going to talk to. So like, basically we had events coming in that would, before they got queued up, go, oh yeah, which company does this, which shard does this company go to? Oh, it's going to be 002. Cool, I'll hop in the 002 queue. And it worked. We knew it would be fine to sort of split out traffic, but really it just means you're just sort of ignoring hotspots. So things that went well: streamlined communication, email sending was on time, events were on time. We didn't go down. That was the best. And new engineers were able to like come on board throughout 2017 and just sort of claim ownership over something important and contribute on the day, which was super valuable. So yeah, we sort of codified some things based off of that and how we approach Black Friday in the future. And we know that culture drives change. It's like starting and making sure that the people you're working with feel confident that even if they haven't like faced a huge scale event like this, that they're doing something useful and understanding something important is really helpful. I guess they're giving me the cane, turning the lights off. Knowledge sharing, ownership, you know, huge failures. It was really painful living through 2016, but there are also huge learning opportunities. And it's a delicate balancing act that we still do. Need to fix the tech debt we have now, preparing for things that we don't know are going to go wrong. So yeah, that's the preso. Do you guys have any questions? Yeah, maybe.
Outside of constant monitoring, what degree, other than constant monitoring, other than constant monitoring? I'll just yell.
Yeah.
Say that you have your website running and you make a decision before you go to work about the website. How would you, other than artificial testing, I guess, prepare for too many connections versus not enough connection? Like you were saying, you shard the data. What are like 3 things you would probably do to prepare for a non-monitored database or models? Maybe if you go specifically sharding and modeling, if you could say specifically how you would do that.
So the question is, if I wasn't allowed to monitor my system and I have a database that I think is, that's a hard question in a way. It's an interesting question, but I can't stress enough how important monitoring is, because you can't really draw conclusions about your system without data about it. But I think what you're asking me for is like some general patterns that work. Is that accurate? You know, sharding is definitely really common, and so, like, at the end of the day, if you just are getting more rows of your data because people are using your platform, you know, table size is going to affect the throughput of any of your IO. So you're going to want to shard them out. There are a lot of common things for this. There's, you know, you can do it based on tenant ID. So this is like your primary key, and you can split that out. That can lend to hotspots, as I was kind of talking about. So like we have those companies that have millions of customers. Every time they send email, that's millions of rows in our recipients database as opposed to the thousands. So whatever shard they're going to be on is hotter. So then you could say, all right, I can maybe do something a little more more sustainable and do kind of date-based sharding as well, where you just sort of close windows moving forward. So I think that's kind of one of the most popular strategies for sharding, where you kind of do tenant ID plus time window is a big one. As far as like the connection thing, you know, connection pooling is definitely helpful. We've had some pretty good luck with proxy SQL. There's some gotchas there. We're still fighting some interesting things there, like proxy SQL connection limits getting hit, and surfacing the exception as I'm looking at somebody who has been working with this a lot, but surfacing that error as a MySQL too many connections, which is kind of a lie. But in any case, you know, caching can help you not have to connect to your database, but connection pooling is also a very viable way to deal with that. Were there any other specific things that you were? Nope, it's actually going to be your Django app is going to open up per process just one connection to your database, period. No. The actual Unix process. So like when you run your server, say gunicorn, yeah, right, your gunicorn worker, that's going to be a process. For Celery, I will note, you can run that in a lot of different ways, like multi-threaded, multi-processed. And for us, we run, it's like one parent, one child, and each of those Celery procs are going to open up a separate connection to the database. So it's, yeah, monitor your stack. That's better advice than any of the other things that I said. Yeah, sure.
When you do load testing, can you replay last year's Black Friday and then see how your stack does, or is it still all synthetic?
Yeah, that's a really good question. We kind of, so I said site reliability engineer before, and like, so we get a lot of requests from app teams like, oh, we need prod-like data in dev, and it's always kind of like this thing where we get like, it's very hard, it's expensive. It's another thing that's expensive because prod-like data means basically you want a lot of data, and we don't have anything now that lets us replay it. That's kind of like a real nice to have. We're not really set up yet to the point where we're like storing event payloads in mass and be like, oh yeah, let's simulate Black Friday last year. That's going to be big storage cost, but that would be cool. That's also a very good question. I think maybe Andrew could probably speak. Yeah, and I mean, yeah, to that point though, you could also do some things where you sort of anonymize it, where like you take those payloads and maybe fuzz the data and say like, you have the same key names but different values, so it has nothing, doesn't represent the companies that it initially came in from. But for instance, if you have, if you want to compare, say like, oh, I want one company that sends, that receives millions of events a day and one that receives thousands, and you want it to be realistic, if you just sort of like scrub that data and anonymize it, then you'll have, basically like a reflection of the events that you had on the day, except you can't tell what it was based on, something like that. Oh, right. You mean like when we load test the dummy data? No, yeah. I mean that's the kind of thing where we work with SendGrid and they give us a black hole and we send it off there and nobody ever looks at it because it's fake. So, yeah.
So a lot of times when you have challenging situations, you learn a lot. Can you talk a bit about the process of folding what you learned back into the product and doing things that go beyond mitigation to better process?
Yeah, definitely. So I think one of the things that we did, particularly after 2017 Black Friday, was sort of had a little bit of a roundtable discussion, and we kind of categorized the things that were tech debt leading into the scale event and tech debt coming out of the scale event that we'd have to fix. We do a lot of things now where we have working groups where, it's not really a dedicated team, but it's just engineers who are particularly interested in a certain challenge area. So, to talk about something like it could be onboarding, where like, how do we get people ramping up really fast? I guess that's sort of tangentially related because I'm talking about people coming on and feeling useful. There is a working group that is tech debt working group that is absolutely like, it's just the list of, rank order, what's the first thing that's going to blow up on Black Friday, that kind of thing. So working groups have been pretty helpful. Other process things, I don't know if you guys have any specific things. RFCs, that's a really good one too. Yeah. big system designs, anything that we think is going to take over a week for a sort of complete feature or infrastructure change, you make just a Google Doc with an RFC where you say, hey, here's my idea, here's how I'm thinking about doing it, get feedback and buy-in from everybody else. So keeping people apprised.
Yeah, I would say another big change was like, I think in like 2016, 2017, like we would tell like the sales team, like, sorry, you're not gonna get any new features like the back half of the year. We're like busy prepping for Black Friday, but we've been trying to solve that like as we build new things, just to make sure we bake in scalability and performance considerations. And so like part of the RFCs is like literally, okay, this is the data model, this is the overall like latency per operation, like what actually hits RAM, what goes to the disk, how many records we expect in the system over time. Yeah. And when we go and like redesign a system, so we like resharded our recipients database and had 50 billion rows in it when we did that last year, but we actually like planned for it to store like 1 trillion rows in it because we didn't want to have to redo this anytime soon, even though we've made other optimizations to it. But really like 1 trillion sounds like a massive number, but that's really like 3-4 years of growth for us. And so we try to like do this heavy lifting once and make it like just kind of stand the test of time.
I'll just add one other thing as well, that on the SRE team, we have sort of codified this thing that we call the launch readiness criteria for any given service, which are just sort of pretty generic questions that you should be able to answer if you are launching a service. How are you going to deploy this, right? What are the acceptable failure modes, right? What happens if you can't connect? All these sorts of things. I'd say going into 2016, really coming out of it too, the SRE team was what, like 3 months old or 4 months old going into Black Friday 2016. And it was 2 app engineers, and then one person left, and then I joined after Black Friday 2016, and I started as an app engineer. So like we didn't know what an SRE was, and like we were kind of figuring it out. So like that's another big reason we didn't have a lot of the process, and we were sort of figuring it out. But yeah, like I'd say like to sum that up, working groups, RFCs, launch readiness criteria, good onboarding, like all those things help.
You've spoken a lot about sharding. Do you have any reporting considerations or things where you end up being pull that data back together cohesively, even though you've broken it down by
so that, yeah, that's a good question. So like you're saying where, are you thinking about a situation where it's like, oh, well, actually we needed that join to work or something like that? I don't think that's ever bit us. It's definitely something that we need to comb through and make sure. So one of the things, even before we even did the functional sharding, where we would just split out entire tables, that I think worked in our favor, was that we really use this one tenant ID everywhere. And if you have that ID, it might be kind of a pain to, you may have to make a second query before you're making the query that you actually want, but you can get to pretty much anything. So I think like having a good universal tenant ID is one good way to work around it. I don't know if I have a good answer to that, because I could definitely see it being like, it's just a challenge. And that's a hard data modeling problem to, because I don't think you're going to know out of the gate what you're going to need to shard. And it may require a migration to a different data model before you can actually make the sharding work. As long as you've enumerated your query patterns, that's probably a good way to make sure that none of your queries are going to break. So. Yeah, I thought I saw. Oh, yeah.
Yeah, I have the mic. It's a very nice talk. I have 3 questions for you.
Yeah.
Connection pooling, postfix issues, and monitoring.
Oh, okay.
So the connection pooling, you mentioned connection pooling proxy. So I was wondering, are you using Django's built-in connection pooling, or are you using some third-party library or tool?
No, we're actually using proxy SQL. I will also mention as a caveat, we're on a very old version of Django. It's embarrassing, and I don't know when the connection pooling, how long connection pooling has been around.
I think it's Django 1.8.
What's that?
Django 1.8. I think it comes.
1.8.
1.7. Yeah.
Yeah. No comment. We use proxy SQL, which is an open source thing, and we basically just run a cluster of those auto scaling groups in AWS, and it's interesting. So basically what happens is as our Celery workers scale out, they fire off their connections to Proxy SQL. And if you're looking at the databases that Proxy SQL then connects to, they will immediately go and you'll see a flare up in those connections, but then they'll peel back because Proxy SQL doesn't manage persistent connections. So you have all those, like that 16,000 plus connections to the Proxy SQL cluster. And that's nice because like that's a very simple auto-scaling group that if it's more connections than any one instance can handle, you just scale it out more.
Okay.
Yep.
You talked about postfix queuing issues. How did you resolve those?
So I'm not the most experienced with postfix. I think one of the big ones was a database authentication thing that it did, where every you might remember the details better than me, but so like every postfix request has to go and like get credentials from the database. And I think there's like a very simple setting you can tweak to cache that. So, you know, that was just us not really understanding the software we were using. Does that sound accurate too? Yeah, more or less.
So when I went to the bathroom, I seen your big monitoring TV. I thought it was really neat.
Yeah.
And you talked about the whole stack you used. So how hard was that to build, and how do you collect the metrics from your different applications, and why didn't you use something like, say, Prometheus or Zabbix or something else? And
yeah,
that's my last question.
Sure. Yeah. We've talked on and off various times about you know, maybe using sort of cool paid monitoring solution, things like that. As long as I've been here and prior to that, it was just StatsD because it's just a really easy way to get code level metrics. And I think that the time that we talked most about potentially replacing that was before we figured out how to really get it to work without packet loss. So I maybe glossed over this a little bit. So you know, we fire off UDP packets from statsd, and we just had that one instance. And one of the things that was kind of this head scratcher for a while after 2016 Black Friday was just, you know, you'd go and watch Netstat. And you just like, if you watched like -su, you just watch it and see, you know, packets are coming through, and then all of a sudden you'd see a bunch dropped, and you're like, what's going on here? And it was basically what we eventually realized was this wasn't really, you know, we thought, oh, it's maybe StatsD can't keep up. No, maybe not that. Maybe Carbon can't keep up. It was actually an AWS networking limit that we were hitting, and that where we were like, okay, so like, this isn't our open source software failing us. This is just our cloud provider. So when we figured that out, basically splitting out the Brubeck daemons. So we basically have, it's silly because a real hardware instance can handle many more packets than these EC2 instances can. But we just have this army of Brubeck instances that really aren't doing a lot except forwarding packets along to get around these crazy EC2 network bandwidth limits, and forwarding those on to Carbon Relay. So it's just worked for us really well. I think I think it's pretty like largely across engineering here that everyone feels really comfortable adding new StatsD metrics. I've gotten a lot of really good like smoking gun moments just adding the right dimension to a key and seeing like, oh yeah, like this big latency graph, once you split it out by cluster, like that's the one that's causing us problems, like that kind of thing. So it's just been great. I think it's pretty simple. Like you need good key structure in Graphite for sure. I think that's really the thing that if you get that wrong, it could really be annoying. But they've got decent enough docs, and I think that after a lot of trial and error, we just have good keys. And like there's definitely times where, you know, if a key's not working out, you just throw it away and try a different way. But yeah, and I think later versions of Graphite support sort of like tags, key value pairs that you can attach to a metric, kind of like InfluxDB. So, sure. So there's a lot of work right now to not use counters in Cassandra in general. What I'll say is, to maybe clarify that a bit, it's literally what the database, what Cassandra requires for counters is, so we're on EBS, which you get much slower. It's network storage, so you get much slower throughput than if you have an actually physically attached drive. Netflix kind of wrote this very famous paper saying that like EBS is actually fast enough for your Cassandra workload. And they sort of say, here's how, if this is how many IOPS you're trying to achieve. And so the sort of line of thinking before that had been, if you're not using physically attached storage, you're never going to hit your throughput requirements. But Netflix did a bunch of benchmarks, and it's like, if you Google Netflix EBS Cassandra, it's like going to be the first hit on Google. And so that's all true for like time series data and things that are generally using Cassandra in sort of good patterns. But with counters, write and then bounce. And but with counters, every operation you do is an update. There's no real insert for counters, so it needs to read from disk, or if your cache is big enough, from cache. But still, you're still reading, getting back a value, and then incrementing it. So you can never say, this is my counter foo, make it 5. You can only say add 5 to it or decrease 5 from it. And because of that, what we were seeing is on this very write-heavy workload from the app perspective, we had twice as much read traffic going over the disk than write. And that's when we realized, like, it's not even spending its time writing the data. It's just like reading. It's this overhead just to make this data type work. So anyway, what we have now is just a massive cluster. We've done a lot of tuning and trying to get it to work okay. It's in better shape now than it's ever been. A lot of that has to do with app side work that we've done to sort of change those workloads. And I don't want to get too into this, but yeah, cool. Yeah. Oh, yeah.
Just to keep track of questions, we're going to pass the mic around.
I just had one quick question about just understanding how just websites work as a whole and just like backend stuff. Is it normally when handling a lot of traffic just like trial by fire, or you just like try to understand like, this is how much we're going to potentially end up getting in terms of seasonal just like traffic? Like you guys might end up getting screwed in like December versus something like coming January and stuff like that.
Yeah, it's really, it's almost like a game where you're trying to make the best estimates you can with the data you have. And so I guess like the only advantage you really have is starting small, where the amount of traffic you're going to have isn't going to push your tech to the limit. And the best thing you can hope for is for a steady incremental ramp up, where you're like, this is how much we grow every day, or this is how much we grow every week. But like the thing that's really hard about once a year scale events is that the best data you have to go on is how much traffic you got the year before. And like you can kind of try to do a bunch of stats and guessing based on like, this is how much our daily traffic increased year over year from last year. At the end, it is very much a guessing game, and you will probably experience some pain. I think like if like talking to a lot of people in ops roles or SRE roles, like nobody doesn't have more stories about like fires and bad times than they do fingers on their hands. So like, you're going to have some painful times, but they hopefully not business endingly painful. And those are the things that you can really prevent is like, there are some like really good best practices out there to make sure that you don't have catastrophic failure. Like, backing up your data loss is probably what customers consider the most intolerable failure. You can't lose their data, like absolutely not. If you have a day where your workload is really slow, let them know as soon as possible. Like communication upfront, absolutely. One of the things, like nobody's stupid, and if your site doesn't work and you're not telling them that, they know that your site's not working. or if you don't know, you need to know. So like, yeah, like that's like your customers is smart. And yeah, I guess that's kind of, I'm ruminating a little, but it's, yeah, you'll have some days where the traffic's too much.
Hi. So I guess kind of going back to the Cassandra thing, I guess my question would be, so if counters are such a problem, what do you use instead of a counter?
Yeah, that's a really good question. It's the counter data type in Cassandra, and I probably can't talk much about the system that's being built here, but something you can think about is if the limitation is this data type doesn't work, you need to figure out some other way to compute your counts and store them. And there are a lot of cool, you know, it's a hard problem, believe it or not. Like counting just turns out really hard problem to do it a lot. And I don't necessarily have the answer. One thing I can tell you for sure is like the Cassandra counter data type, not recommended. Yeah. Oh, you know, I'll add to that. A big problem is that we do a lot of this, like the reason that we do these massive amount of counts is specifically because the segmentation that we do is in real time, where if you ask us a question like, you know, yeah, give me any customer that bought 5 things in the past month, we can go to Cassandra, and the data model is such that it's in the abstract a really efficient query. It's because of how many of those queries we make that it's slow. But what a lot of other companies will do is they'll do that. They'll try to process things like that in like a batch Hadoop type job, which is not real time. So it's like it'll take days, and we can do it in like seconds, or maybe if you asked us a lot of time, minutes. So.
Any final questions, or does that wrap it up? All right. Well, thank you,
Cool.
Paul.
Thanks, guys.